Hey everybody, I hope that you were able to at least give these 3 problems a try. I'm going to work through the answers, and if you find yourself struggling, please make sure that you come and ask questions during our Google Meet time. So we're going to start off our problem with the question for A, where it says 80.0 grams of I2O5 reacts with 28 grams of carbon monoxide. Determine the mass of I2 that could be produced. So when we do our stoichiometry, we've always said that we want to make sure our equation is balanced. So I've got 2 iodine and 2 iodine. I have 5 carbon and 5 carbon and 10 O's and 10 O's. So I'm all balanced out in that department, so we're good to go. So in this problem, the next thing I always tell us is I want to figure out what we have and what we are solving for. So I know that I have 80.0 grams of I2O5 and I have 28 grams of my carbon monoxide. Now this is how I can recognize that this is a limiting reactant problem. I'm given both reactants and it's asking me to figure out how much iodine in grams I'm going to make there. So I need to solve for that. Now, like I said, there's 2 approaches for the way that you can solve this. I will show you approach 1, and then I will show you approach 2, the one that I prefer. So here is approach number 1. And approach number 1 asks you to pick one of these chemicals and solve for the other reactant in the problem. And what this is going to do is it's essentially going to say, like, hey, I want to figure out if 80 grams of I2O5 are going to completely react, how many grams of CO is that going to take? And then I'm going to compare and say, do I have enough? So I'm going to start off my stoichiometry with my 80 grams of I2O5, and like we said before, in stoichiometry you're going to convert your starting information into moles. So if I add all of that stuff up, I get a molar mass of 333.8 grams for 1 mole of I2O5. Okay? Then I'm going to convert it to moles of CO using my mole ratio. So for 5 moles of CO, I'm going to have 1 mole of I2O5 that need to react. And then I'll solve for my mass of carbon monoxide, and that is 28.01 grams of carbon monoxide for 1 mole of that carbon monoxide. Now you notice I kind of left the grams off here. The grams, I guess, of the chemical type aren't the most important in terms of these conversion factors. What are super important are the moles here. So if I leave these moles off, I'm definitely going to lose points on there. Cannot be implied. They have to be very specific. So like if you would leave off and just have 5 moles and 1 mole, I would not give you credit for that. So if I go through and I put this into my calculator, I end up with 33.57 grams of CO. Okay, so again, the hard part with this now is remembering what the stoichiometry is asking us to do. So this is essentially saying if I want all 80 grams of I2O5 to react, I am going to need 33.57 grams of carbon monoxide. And if I look at how many I have, I don't have that many. So I do not have enough CO. So that means CO is my limiting reactant. Okay. Then what I would do is I would take that limiting reactant and I would solve for my theoretical amount of I2. There's a couple issues that I always take with this route. One, they're probably never ever going to ask you what's the limiting reactant. You're going to have to do the work and solve for some sort of yield one way or another at some point. So I think it's kind of just a little extra work. And this comparison here can be tricky for people to make. So if you're like, oh, 33.57 grams of CO, I don't have enough, or I have, this is more than this. But if you don't know what you're comparing and you're not careful, it can be problematic. So I'll show you a way I prefer to do it. It's a little bit more work ahead of time, but it's going to get you the same answer. So like I said, I would need to take this carbon monoxide and solve for my iodine then. So I'm still doing 2 lines of stoichiometry essentially. So what I'm going to do is I'm going to instead take my 80 grams of I2O5 and solve for iodine, and then do the exact same thing for carbon monoxide and solve for I2. In this situation, whichever one comes out to be the lower amount is going to be the one that's caused by my limiting reactant. So I'm going to start over. 80.0 grams of I2O5. 1 mole of I2O5 over 333.8 grams. So starting off almost identical. I'm going to convert from moles of I2O5, but now this time it's going to be 1 mole of I2. So I'm solving for my product right away because it's asking me about that I2 in my problem. The molar mass of I2 is 253.8 grams for 1 mole of that. And when I put that into my calculator, I am going to get 60.82 grams of I2. Now, what does this tell me? It tells me that if every single last little tiny gram of I2O5 reacts, I should expect to get 60.82 grams if I have unlimited other reactant. So if I have excess of this carbon monoxide. Then what I'm going to do is I'm going to repeat the stoichiometry using my mass of carbon monoxide. So I have 28 grams of carbon monoxide, and now I'm going to convert this to moles by using its molar mass. 1 mole of carbon monoxide is 28.01 grams. Now I've got to look at my mole ratio. For 5 moles of carbon monoxide, I'm going to produce 1 mole of I, and then that weighs, again, 253.8 grams for 1 mole of I2. So you can kind of see the starting is different, but the starting is different, but the end is kind of the same. And when I put this into my calculator and I solve, I get 50.74 grams of I2. So if I compare now, if all 28 grams of carbon monoxide are able to react with a complete excess of the I2O5 up here, I could only produce 50.74 grams of iodine. So when we look at this then, the lower amount of the two is going to be my theoretical yield. That I'm going to make. And that's caused by carbon monoxide. That's my limiting reactant. The I2 is not the limiting reactant, but it's caused and created by that limiting reactant of carbon monoxide. Okay? So the second question then is determine the mass of excess reactant left over. So if carbon monoxide is my limiting reactant, then my excess is my I2O5. So this is where our stoichiometry skills kind of have to come into play a little bit here. So if I think about this, because carbon monoxide is my excess reactant, it means all 28 grams of this are going to disappear and go away. I need to figure out how much of this reacted in that process. So if it feels like it's more stoichiometry, that's because it is. So for my excess calculation, I'm going to go from my limiting reactant to my excess to figure out how much was used. Okay. I would not go from my theoretical yield just in case I screwed that up, just as a heads up. So I'm going to start over again with more stoichiometry. 28.0 grams of carbon monoxide converted to moles. Okay. Mole ratio comes next. 5 moles of CO. I got to go back and double check here. It's 1 mole of I2O5. Okay. And then 1 mole of I2O5, and then we'll check that mass up here, which is 333.8 grams. Okay, so I'm going to put this into my calculator, do the stoichiometry and the dimensional analysis, and I end up getting 66.74 grams of I2O5. Now this number here, again, what this tells me is if all 28 grams of carbon monoxide react, it's going to use up 66.4 grams of I2O5. From the beginning, I started with 80 grams of I2O5, and I used 66.74 grams. So if I do the subtraction for those, I get a difference of 13.26 grams, and that's how much I have left over, okay? So there's lots of stoichiometry, more than you ever could want to do in your entire life. Okay, last problem. If 45.3 grams of I2 are actually produced, what is the percent yield? So percent yield is the actual amount you got divided by the theoretical. Our actual is going to be the 45.3 grams. Now, the theoretical is always the lower number that's produced in your limiting reactant calculation. So I'm going to put 50.74 in my denominator and then divide those two and multiply them by 100%. And when I do that, I get 89.2% when I type that into my calculator. Okay, that's a pretty good yield, all things considered. So it's not too bad of a job for whoever did that process. Okay, there are lots of things to know with this. The biggest thing I would take away is that you need to be very clear about what you are solving for and why, and what that tells you. So if I go back to my equation up here, if I compare from iodine or I2O5 to iodine and carbon monoxide to iodine, what I'm comparing is how much of this I could make. If I'm going from here, CO, to this, it's asking, or it's telling me how many grams I would need to react with all of this 28 grams. I could also go the other direction to the carbon monoxide and it would solve the same thing. Okay, so stoichiometry is very powerful, but you have to be intentional with how you're doing it and what makes sense. Okay, if you find yourself struggling with this, please make sure that you ask questions and come to a meet. Otherwise, good luck, guys.